Welcome to Action Geometry. Again, here we go. Going to work on the first 3 pages. Bunch of basic shapes. Doesn't get any more basic than this as far as action geometry goes. These are shapes that demonstrate the symmetries and scales that we care about. What you're seeing here is in 2x speed. That's why it looks a little funny. I'm tracing a shape that I already have. And anybody who's making this book for the first time should have these shapes, because part of making the book is when you're done, you make a few sets of shapes to spread to the next person. So you have the shapes to trace. You make little dots on the triangle where the little triangles go, and then you can use a ruler to connect those dots, and you get a triangle made out of 4 smaller triangles. Ready to color in. Now we do the same thing with the square. Again, I have a shape that's already been cut out and laminated, colored maybe. In this case, I don't have it colored, but it can be colored for clarity. Again, I draw little dots to connect with the ruler, and I connect the dots with the ruler to make 4 smaller squares inside the large square. And there's the equilateral triangle. I mark the angles, 60 degrees and 90 degrees. And I go on to the next page and work with the golden ratio and all of its associated triangles and angles. This is the golden triangle. Golden triangle has a ratio of the golden ratio between the base and the edges there, the sides, the legs, whatever you want to call it. And then I use the cutout that I have to make a bunch of smaller golden triangles inside the big golden triangle. And this is a big part of understanding what the golden triangle and the golden ratio is all about, is just going through the act of making these smaller triangles. That's what really gives you a feel for how the golden ratio works. And I can do the same thing with the other triangle that goes along with that, the golden gnomon, which is also an isosceles triangle defined by the golden ratio, but in this case, it's a different ratio. It's still the golden ratio, but it's a different triangle, if that makes any sense. It makes sense when you see it. This video is really just here for completeness so that somebody can get an idea of what this whole thing looks like. So it's about 2x speed, and I probably edited out about 20% of me looking for artistic tools and flipping through other books and so on. So ultimately, what you're looking at is about 14 minutes according to the wall clock. And then I reduce it down by about 2x, so this is sort of a 6-minute video. So now I've moved on to making the 45-degree isosceles right triangle. Okay, so now again there's a fractal. I take a square and I divide it down the middle along the diagonal, and then I use the square cutout that I have to make a series of 90-degree, 45-degree sub-triangles. So as with all these triangles, I make smaller shapes that are the same as the big shape, a fractal. I decide how far I want to go down. I go down a few, 4 or something like that. And then I mark all these angles. 45 degrees, 36 degrees, 72 degrees, and 108 degrees are the various special angles here. And then how much you care about those numbers depends on what it is you're trying to do with all of this, whether you're doing art or engineering or technology or what. And I label all of these because I think it's important to have that as a reference in the book. If you own this book, you have a copy of it, you flip through it, you can always remind yourself what these angles are. And there they are, all the details. So that's the second set of shapes. Now this third set of shape is 2 triangles, both of which are designed to communicate ideas about the square root of 3 and the 30, 60, 90 right triangle. How much you care about these numbers depends on how much you care about numbers in general. So if you want to remember a bunch of numbers, it's all going to be here, and this is a reference book. But if you don't want to deal with numbers at all, Action Geometry is designed to allow you to use these kinds of symmetries in your art or design without ever dealing with the numbers. So you can get an intuitive feel for what these triangles can be used for. Whether a triangle is the kind of thing you want to use for 6-fold symmetry, 5-fold symmetry, or in this case, we're working with 30-degree angles, so I guess you could think of it as 12-fold symmetry. which gives you the hands on a clock or the signs in a zodiac. It comes up over and over and over again in different kinds of geometric art. And it all goes back to the square root of 3. The square root of 3 will appear over and over and over again in fractals based on hexagons. Anything that has to do with a hexagon, the square root of 3 will make an appearance. The triangles that we're building here are little pieces that you can use to build up a hexagon, so that when you cut up a hexagon, the pieces of that hexagon end up looking like these triangles. The equilateral triangle, 30, 60, 90 right triangle, and various ways that 30, 60, 90 and equilateral can get put together or taken apart. And now I'm labeling everything, making sure I've got all of the ratios and angles so that this is a proper mathematical artistic reference book when we're done. More labels. Contemplating the labels. Is it done? Yes, it's done. And here it is. The end. Yep, now we flip through it. I got this book here, I'm flipping through it, and there's the first 3 pages. The next step is going to be to color that in, which is a separate video. Action Geometry!